Howdy there, Internet students. This is Mr. Hermanson. This is lesson 7.2b. We're going to be talking about compound inequalities today. And on a graph, compound inequalities can be represented by like more than one part of the graph that are included in the group. Okay. Go ahead, if you want to pause and read the main idea here, you can do that. I'm just going to get into problem one here. It says, what compound inequality represents each given phrase? All real numbers that are greater than 1 and less than 5. That would look like this. So we're going to use an X to represent all real numbers. Now remember, those don't have to be like whole numbers. They can be any kind of number, like integers, fractions, whatever. And it says greater than 1 and less than 5. So X meaning the same set of numbers are also less than 5. Now, when it's a compound inequality like this with the word and, basically 1 and 5 are the boundary points. So there is another way we can write this a little simpler. We can just put the X between the 1 and the 5 and write it like that. So an example of a solution to this set would be like 4.6, because 4.6 is greater than 1 and at the same time it's less than 5. Okay, the second part here says all real numbers that are less than 10 or greater than 15. When you see the word or in there, that means there's like, there's going to definitely be two parts of this, and it'll look like this. So we want them to be less than 10, or my group of numbers could be greater than 15, so that looks like that. Now this I can't really write into one simpler problem because there's actually two separate groups. Now when we make a number line, you'll notice that distinctly on this first problem, part A, we're going to have numbers that are greater than 1, and then we're going to go all the way up to 5 on the number line. So it'll be numbers like in between the two. Where on the second one here, to get numbers less than 10, so if you find 10 on a number line, numbers less than 10 would be the numbers this way from 10. And then greater than 15 would be numbers that continue above 15, like these. So there's two parts of the number line that are represented by the numbers. Okay, I'll work out this got it part for you, but if you want to just pause here, you can. So here's what the solution to that problem looks like and how you would graph it. So a solution of a compound inequality involving and is any number that makes both inequalities true. That would be a situation like the one above. Solution of a compound inequality involving or is any number that makes either true. All right, you can solve a compound inequality just like you solve normal inequalities. And in fact, in a situation like this one, which would be an and inequality, so x plus 2 is greater than negative 2, and x plus 2 is less than or equal to 5. In order to get x all by itself right here, we need to get rid of that plus 2. And we can, to get rid of that plus 2, we could just subtract 2 from this middle part here. But remember, whatever you do to one side, you have to do to the others. And in this case, there's actually 3 parts to this that we need to subtract 2 from. So we're going to subtract 2 from each of those parts. And we end up with negative 4 is less than x, which is less than or equal to 3. Okay, and then to graph that, I'm just going to start here with negative 4 over here somewhere. That would make 0 there and 4 here. And so we're going to put an open circle at -4 and a closed circle on 3. And then and means we are finding all those in between the two of those. So I'm going to color it in like that. All right. Go ahead if you want to pause here so you can try this next one, see if you can get it. And then you can start the video again to see if you were right. Notice how to graph that. I used a scale of 1/3 on my graph. That helped it so it was easy to find 2/3 on the graph. All right, so writing and solving a compound inequality. It says to earn a B in your class, you must achieve an unrounded test average between 84 and 86 inclusive. Right away, that tells me that I'm going to have one of these kind of compound inequalities where I'm going to have 86 on one end and 84 on the other. It says you scored 78, 78, 79 on the first 3. Is it possible for you to earn a B in the class? Assume 100 is the maximum grade you can earn on the test. So if you add the 3 scores you already got, that would be 235 total. And then I'm going to add one more score to that. And I'll just call that X. Then if I divide those by the total number of scores, which is 4, that should give me my average. So now to get rid of this divide by 4, I'm going to multiply each side by 4. Then I'll just subtract 235 from each of the parts. And after subtracting 235, I see that as long as I have a score somewhere between 93 and 109, I should be able to get a B in the class. All right, so you go ahead and try this problem, and you can check back if you pause right now. All right, so now in this last problem, we're going to do some problems that involve OR. When you have OR, you really have to write them out 2 different ways to cover both cases. So what we're going to do is just solve both of those inequalities. So on this first one, I'm going to add 1 to both sides. And then I get 2n is less than -2. Dividing by 2 gets me n is less than -1. Or on the other side, I'm going to subtract 2. That gives me -3n is less than -6. Dividing by -3. Now remember, when you multiply or divide by a negative, you have to flip the sign. And so I get n is greater than 2. So my final solution is n is less than -1 or n is greater than 2. Now when you graph that, you actually have 2 different parts to your graph. The n is less than -1 part, and the n is greater than 2 part. All right, so go ahead, you try the next one here. And you can pause now and then check back for the solution if you'd like. So that solution should look like this. All right, I think you guys are ready for your homework now. Give it a shot, and good luck.